Good morning, everyone.
Good morning.
Can you hear me clearly?
Yes.
Okay, Latifa, it's fine. When you had the appointment? Okay, so I have very few students today. Just check outside. It's fine. Okay, please go to the Moodle and download example number 4.
Miss, can you check the chat, please?
Okay, 1 minute. Yes, I just checked. Are you Latifa? Who is there? I just check your message. It's fine. When you have the appointment?
Now, Miss, I'm on my way.
We want to go now.
Yes.
Okay, it's fine. I have your student ID, so I will mark you present.
Okay, thank you, Miss, for your understanding.
Just when you come back, see the video, okay?
Okay, Miss.
Okay. Now, so all of you go to the Moodle and download. Go to 341 and go here, lab work, and example number 4, lab number 4 example. All of you on Zoom also. Okay. Done, all of you?
No, Doctor, just wait, please.
Yes, I'll just see how many students on Zoom. Only 6 students today. What happened? Why students are not coming today? This is section 1. And this is section 1. 3. Just check how many students are there. $13. So I just have 6, 7, 8, 9. 3, 4 students are absent today.
Miss, I have online exam after this class immediately, so that's why I couldn't come to the campus.
What's your name? When
Ali.
you have Ali? When you have the exam?
Me too,
After
Miss.
this class immediately.
Immediately, like at 11. So I will today we don't have so much to study because it's only one topic. So it's fine. I will try to finish the class early today. Okay. So today the topic is amplitude modulation. So all of you may be familiar. Are you studying communication system course also? Theory course. So what is amplitude modulation? What is modulation? Modulation is transmitting your signal with some carrier wave. For example, this is your signal. This is your signal. This is my carrier wave. Okay. You will multiply this signal, you will transmit over this signal, and then you will transmit this. Why we are doing this? We are doing it because we don't want that the information should not be lost. Okay, so this is our purpose. That's why we do modulation. What we do is we put our message signal over the carrier signal, and then we transmit it, and then because of this carrier is always high frequency signal, so that our information is not lost. Okay. Today actually we are studying double sideband suppressed carrier. It means that there will be amplitude modulation, and then at the receiving end there will be suppressed carrier. The carrier will be lost. Okay, and we will have two side bands where we have all the information. All the information will be in the side bands. So here also this is message signal. This is carrier signal, and then this is amplitude modulated signal. What does it mean? That the amplitude of the carrier wave is changed. That's why it's known as amplitude modulation. So if it is frequency modulation, then frequency of the carrier wave will be like this, changed. In this case, the amplitude is changed, right? So in this lab, we will generate an amplitude modulated signal, double sideband stress carrier, and to analyze, we will analyze this signal in frequency domain and time domain. Okay. So the modulate, what is the modulated signal? The original message signal. Okay. The carrier is the carrier. This one. This is message signal. This is also known as modulated signal. And then the received signal. Yes. Now you all know that what is the frequency, how we can calculate frequency? 1 divided by time. The reciprocal of time is frequency, right? And then angular frequency, omega is equal to 2 by x. In the previous lab, we studied this also. So what is happening here? This is our time scale starting from 0. Then this is our increment time. Increment time is equal to sampling time. Okay, sampling time is equal to 1 divided by fs. We know that t is equal to 1 divided by f. Right. So this sampling time is equal to 1 divided by fs, sampling frequency. And then what is this? 4 is the number of cycles. So this is the number of cycles multiplied by cycling time. So this is number of cycles in the message signal divided by the frequency of the message signal, right? M is the frequency of message or modulated signal, right? So this way we define the scale. Now, just an example, if you have some, so if you have any vector, right? This is an array of vectors. So if you write in MATLAB length of this vector y, then it will give you length. How much is the length? It will count all the values and then it will give you the length. Now line space, what it will do? It will equally space all the numbers over the length. Okay. So what does this command do? It is x2 minus x1. MATLAB will do this divided by n minus 1. So x2 is equal to 81 minus 9. Internally, MATLAB will do this. Okay. Divided by n is the length. N is equal to 9 here. Here we just calculate 9 minus 1. So this will give you. It will give you 9 at the end. So it will give you this answer, and now this will distribute all the scale with equally spaced vectors of 9. Okay, so the space between them will be 9 elements. So equally 9 elements, right? So then, so this returns the length of the vector. So this will define the vector. So this is the first value, last value, and then this is the number of turns. Now two parameters are used to define any periodic wave. In the previous labs also we studied A is the amplitude, and then omega naught is equal to 2 pi f, which is angular frequency, right? So this is here. Now in the previous class we studied what is FFT of X. Why we do the FFT? It gives the frequency domain analysis of any time domain signal. Okay, this computes the discrete. If you have some samples like this, if you apply FFT on it, it will give you frequency domain analysis like this. So this will give the FFT of any discrete samples of X. Okay. So this FFT of Xn, this gives you the n points. So how much number of points you want, so you can write this, and then it will give you the FFT over that number of samples. Then with this you will normalize it. How much, like it can be from 0 up till 0, 1 up till infinity. So you can, these are all the things which this will normalize your complete signal. Okay. So now FFT shift, in the previous lab also I told you what FFT shift will do. It will make a scale across 0, and then equally it will distribute the frequency arrays. It's written out also here. It rearranges the Fourier transform by shifting the 0 frequency component to the center of the array. It will shift the 0 frequency component across the 0 axis. Okay, equally distributed. So this is 3 plus 4i. This is complex. This is complex number. ABS of C, what it will do? In previous class also I told. It will give you the absolute number, the amplitude. How? MATLAB will do this. 3 square plus 4 square, which will be equal to 9 plus 16 square root. This will be 25. So this will be 5. Internally, MATLAB is doing all these calculations internally and then just giving you the result. But at the back side, this code is written. Okay. Now, absolute value in the previous lab also we did this for plotting the Fourier transform. So absolute value is this, and then FFT shift of FFT of X of n and normalized over the total number of samples. First, calculate FFT, then you will distribute it equally across 0, and then you will take only the amplitude positive. It will always give you the positive number, and there will be no complex value. Complex value will be removed. Okay. So now, what happens in the suppressed carrier? It means that you have your message signal. This is my message signal. This is my carrier. And then at the output, you will get 2 bands. And then this carrier will be lost. It will be suppressed. Why? If we transmit carrier, it will make a loss of power. So only these bands will have all the information of the message signal. All the information of the message signal. So this carrier will be suppressed. Here you can see this carrier, but here the carrier is suppressed. There is no carrier. Okay. This happens in amplitude double sideband suppressed. So this is lower sideband, this is upper sideband. This has all the information of the message signal. Okay. So what happens in the double sideband suppressed carrier modulation? So your message signal is this, M of t, right? Then you will multiply it with carrier. I just told you. For example, this is my message signal like this. Then this is my carrier. Okay. I will multiply message signal with the carrier. Okay. Then this will become x of t will be mt multiplied by square root of 2 cosine of 2 pi fc, right? Then you go to the channel, it will transmit, and then when you get the signal, what will happen? You will demodulate it. You will remove this carrier frequency component from it, and then you will pass it from low pass filter, and then you will get your actual message signal. Actual message signal. Okay. So what is y of t? Y of t is equals to this one. M of t multiplied by carrier square root of 2 cosine of 2 pi fc. Okay, so this is the same thing. So here m of t multiplied by this carrier mt multiplied by sine of fct. This is x of t. Then y of t is equals to x of t. It means here at the channel you get this modulated signal. Same this. This is equals to y. And then here at the output you get so then for the new modulation you will multiply it with the demodulated phase. Okay, so what will happen here? So this is equals to if you will multiply it, for example, you had this signal, then if you multiply it with AC cosine of 2 pi fc, so you get this. How I am doing it? So here y of t is here, right? Y of t is all my this signal. Then I multiply it with demodulator, which is this. So what will happen? AC square cosine square of 2 pi fct, right? This will become like this, right? Then there is a formula for this trigonometric identity, which is equal to, I think, 1 plus cosine of 2 alpha divided by 2. This is trigonometric formula. Okay. So you will put this here, and then you will get this value. Okay. This is just a formula. I just implemented this formula. Okay. Then you will get this. Okay. Then at the output, this your actual message signal will become m of t multiplied with amplitude square divided by 2. And then this 2 came from this formula. Okay. When I open this trigonometric function, you know this trigonometry, this formula. Are you familiar with this one? Okay. So this is my message signal. This is my modulated signal. Okay. Then this is my message signal in frequency domain. This is my modulated signal in frequency domain. Now this is transmitted signal. This is actual signal we received, and then this is the frequency of this signal, and this is frequency domain of this received signal. This is received signal. This is modulated signal. Okay. So now we will do this, all of it. We will plot this. We will review it. That how we will multiply this message signal with carrier frequency, and how we will do its frequency domain analysis. So we will just implement this up till here. We will just generate a message signal, then we will multiply it with a carrier signal. That's it. In this lab, we will only do this part. In the next lab, we will do this part. Okay. So there is an example. Use MATLAB to generate the double sideband suppressed carrier. So I was just discussing it with you. So this is an amplitude modulated signal. So the carrier frequency is 154 kilohertz, and the sampling frequency is 100 times. Fs is equals to 100 times, means multiply with the carrier frequency. Carrier frequency. Okay. The frequency of message signal is 10% of the frequency of its amplitude. Okay. signal. First what we have to do is write the message signal, then write the carrier signal and the transmitted signal in time domain. Show 4 cycles. How many cycles is needed? 4. Represent the message signal and the transmitted signal in frequency domain. 2 things. Okay. So first step is define the carrier frequency. FC is the carrier frequency. How much it was given? 154 kilohertz. Right? Is it difficult or there is no response? Is it clear to Zoom members also? I don't know. I think it's a bit difficult maybe. So okay. So FC is equals to 154 kilohertz. This is here. Okay. Define this. Then message signal is equal to FC divided by 10 because it was written here. Frequency of the message signal is 10% of the carrier frequency. Okay. So message signal is equals to 10% of the carrier signal. Okay. Then sampling frequency is equal to 100 into FC. It was here. 100 times into carrier frequency. This is here. Then time is equals to 0, 1 divided by Fs. This is increment and then 4 cycles. This will show 4 cycles of the signal. This is the number of cycles divided by the frequency of the message signal. Okay. So what is the frequency of message signal? 10% of the carriers. 10% of the carriers. Then this is my message signal. Amplitude is equal to 10. It was defined here. Amplitude is 10. All the things are here. I'm not doing anything from my side. All the things I'm just defining in the MATLAB. All the things which are written here, there is nothing like from my side. Okay. Then this is my message signal. Then this is my carrier signal. Okay. Then what happens in amplitude? What happens in amplitude modulation? X of t. Sorry, this is my message. Then here is the carrier. Here we multiply. So this is xm, my message. This is my modulated signal. Xm is modulated signal. So what happens? This carrier multiplied by the message. Message multiplied by carrier. Right? So then you just have to plot. Okay? Up till here only the time domain is. Then the next step is it was here. Then first this we already did. Then we have to plot this signal in frequency domain. Then when you are done until here, this is all time domain. Now here we will do the frequency domain shift. Frequency domain. The same command, absolute value of FFT shift of F is the message signal and N is the number of samples normalized with total number of samples. Okay, then just plot. Okay, plot and subtitles. Right? Any questions? Any questions? Here? Here? So, go to the Moodle and download. Yes, you will. I will you download this file. So, do you understand all of it? When you will do, then you will understand more. It's not clear? Do you have questions? Okay. So, okay, let's start. I know this is a bit difficult. I think you are studying it in communication system. Did you study double sideband suppressed carrier? Did you study modulation? Have you studied modulation? Yes. So this is related to that amplitude modulation. So is it clear to all the people on Zoom?
Yes, teacher. Should I copy this page?
Sorry?
I copy this page for MATLAB.
Yes.
Only
Uh,
this or the next two one?
Yes, because this is starting from here, right? This is the example, okay?
Okay.
And then you have to write all this code.
Okay.
I explained all these commands to you. So it's up to you if you don't write this green comments, but just write these all black ones. So that you can analyze, okay, what is the transmitted wave, what is the carrier wave, and then how it is analyzed in frequency domain and how it is analyzed in time domain. Okay. What's your name? So is this clear that why we are doing all of this? Is it clear? Should I move forward? No. So if you have questions, please ask. Should I move? Should I? Okay.
Doctor,
Yes.
you put something wrong for me.
What happened? Can you share me your screen?
Okay, just a second. Can you see, Doctor?
Yes. So what happened? What is 100 into FC? So what is the wrong? I think you just have to. What is the error? Can you show me the error?
This one. Can I log in laptop and share?
Fine. So FC. No, it's fine. I saw the message. Can you go to the code?
Okay, this is the code.
So FC is the first one. Is this one is FC? So you didn't the first first line. First line. Write the code and then down there. This is FC.
FC this. Okay.
C.
FCC. Okay.
For that.
Okay.
So next is this. Ah, okay. This is not shared. Let me share it. Next is this. So amplitude is equals to 10, then message signal. In the message signal, did you notice that this is the frequency of the message signal? In the carrier signal, there is frequency of the carrier. No, no. No, no, just in front. There is a small bag. Abdurrahman, are you doing it? Abdurrahman?
Yes, doctor. Yes, doctor.
Can you show me?
Yeah, just a minute, doctor. I didn't finish.
Done? Done? Should I go forward? Done? Now this is just plotting. It's up to you. I mean, if you want to. write
Doctor,
it
can you go back? We don't finish, please.
back, okay.
Thank you. Just a minute.
Just don't write these green comments. Only write this, all the black one. And the actual code is here, the black one. These are all the comments. This is for your understanding. Who has interest in communication system? Communication system. Do you like this course? So then this will be your. It will be easy for you. Done. So Khalid, should I move forward?
Okay.
So then, you don't have to write this subplot. this also, because you're, and then this figure also, you don't have to write. Just plot, and then this also cross this one. Okay. You don't need some plot because we are using MLX format. Sorry? Sorry? Table, yeah, it's up to you. This is just to the labeling if you want to. X label and Y label.
What we should we write, Doctor?
Right? Just write this one, this, okay? Then write this. Okay? Then write this. These three. And then later you can add the titles and labels. X and Y labels. But if you want to do it now, just do it. It's up to you.
I write everything, only the green, right?
Sorry?
We write everything, only the green. We didn't write it.
Only which I picked. These tick marks. This plot, and this plot. This is plot of carrier, this is plot of message, and this is plot of the modulated signal. 3 plots. Just for
Okay.
your visualization. Done? And then after this, run your code. So let's see what happens, what kind of figures you will get. When you are done with all the plots, just run it. It's fine, just something.
Doctor, I write the under the plot, the title, and Y label.
Up to you. It's up to you if you want to write. Just titles.
If I didn't write it, there is something wrong will be with the running.
No.
Okay.
Just see your these 3 signals: carrier signal, message signal, and modulated signal. Just want to see 3 signals. And what kind of modulated? Because amplitude is Do you get it? A and then multiply.
دكتور
Doctor, I have some warning.
Warning. Show me. Show me.
Okay, 1 minute. Here.
Mhm. But can you show me your output signals? And then there is error also, imaginary, complex, and wire. So if you go to the code, so title, okay, X level time. So you don't have to just remove this subplot, figure and subplot. Yes.
All of it.
Yes, this figure and subplot is not needed here. Remove, yes, subplot.
This
Delete.
subplot and this subplot, right?
Yes, and all, everything in the bracket also.
All of
Select
a number, right?
all numbers, yes. And then if you go up, this also selected and backspace. And then, yes, if you go up also, there is another also. Yeah, this and figure also delete. Now
Do
run.
it run.
Mhm.
Same.
So this is warning here. LABE. What kind of warning is it? Actually, with the camera, it's difficult to.
Look.
Yeah, your carrier signal is fine, but your message signal is not. Imaginary parts of complex. Can you comment it for some time? I just comment just before title, write a %.
Before of type what?
Write %. Shift and
Here.
5. Yes, shift 5.
Shift 5.
Shift 5. Press shift and then 5.
Here.
All the titles. Press shift 5.
Make run.
Just run it now. Let's see what happens.
Warning.
What is the error? Okay, here if you go m is equals to there, a is equals to 10, and then yes, this is capital A, and then multiply capital A, and then steric shift 8.
Shift 8.
Yes, now run this.
Okay.
Show me, and then now you can uncomment these titles. Go down. Uncomment. No. This one title and all this title backspace. Backspace. No, backspace. Again.
Again.
Yeah. Yes. Now, yes. Then down.
And
Then
make run.
and then go to your code.
It's okay.
So show me the result. Yes, this is fine now. Yes.
Fine, huh?
Mhm.
Thank you, Miss.
What's your name? Thamir.
Right.
Thamir Lanazi.
I can share screen.
Yes. Do you have any problem with the code? Is it running correctly? Show me the result. Yes. Yes, this is correct. Yes. Now you see that we got a time domain signal. Okay, yes. Abrar. Yes, Khalid.
Can I make share?
Yes. Yes, yes. Can you show me the signal? Yes, this is perfectly fine. Go up. Go up from here. This side. No, this other one. This where you have the
32.
where you have the figures, not the code. Yes, it is okay. Yes. Okay. So now you can see that this is you got here. Okay. This is which signal is this? Anyone tell me which signal is this? Which signal is this? Carrier. Yes. Because the frequency is very high. So if you go down, Khalid,
Go down.
which signal is this one? Message signal. Yes. And then if you go down, which signal is this? Yes, amplitude modulated signal. Okay. Here, what is happening? M is multiplied with carrier. This is this thing. Okay. Now, is it all of these signals time domain or frequency domain? All these signals are time domain or frequency domain? See here. Time domain. Yes. This is T, and then we are multiplying with T. All is T. All is T. So all of it is time domain. Yes, Khalid. Now you can stop sharing.
Okay. Shall I share, Doctor?
What's your name?
Abdurrahman.
Abdurrahman. Share. Okay. Yes, show me your signal. Yes. Go up. There is a small error also. Your signal is correct. Yes. So all the people on Zoom, all of you are working, right? So now what is our next step? Okay, yes, Abdurrahman, thank you.
Thank you.
So now this was our original question. So we did this one. First part we are done. Okay. So show the message signal, the carrier signal, and the transmitted signal. We show all three signals. Okay. In the time domain. Okay. All of them we did. Now we will show the same signal, message signal, carrier signal, and the transmitted signal in frequency. That's it. Yes. So we will solve for frequency. First of all, we will define the length. What is x of t? X of t is our signal, modulated signal. Multiply m with c. Modulated signal. Then line space. What does this do? It will equally distribute the axis across the number of sample points. Okay, I told you in the previous also. X2 minus x1 divided by n minus 1. Equally distribute the scale. Okay, then frequency domain Fourier transform. Then FFT shift. This will shift across 0 and then epsilon. Just write this. Is it
Why
clear?
the black coding?
Yes, black coding. Yes. So, did you see here? Why do you think that all these three are same? These three. Can anyone tell me what is the difference between these three? Why we are doing three same commands? What is the difference? Because if you don't ask, yes, exactly. This is for the message, Fourier of message signal. This is Fourier of carrier signal. This is Fourier of modulator signal. Clear? With n, first is n, plot n with n, then n with c, then with x. Yeah, like this. First we plot e with m, then then we got even, XP, then we got so same. Done? Should I move forward?
Doctor, I have something wrong.
Show me. Show me. Yes, show me, Khalid.
Can I make share?
Invalid expression when indexing value. Yes.
Can I press fix?
Yeah, press fix.
ايه في غلط بهذا ايه
Okay, sorry.
Plot. So there's one more thing. You just have to plot. So I go for it. Okay, Khalid. Now the second step is plotting these frequency domain signal. You already did this. Just same. Now here I left my pen somewhere. So here, so write this one, then write this, then write this. So what happens? Okay. Yeah, because now the scale is with line space. Done? Yes. So one, just this is first. Like this, you should get up till 3. How much you are going? Your signal is going up till 3. Up till 3. The amplitude is like this.
Doctor, can you backspace, please?
So okay, here you see he did. There is this axis is also defined so that you think yours is so also write this also. This command is also needed.
Doctor, there is error. He write for me Victor must be the small
Same length.
length.
Show me.
Okay.
Okay. Show me, Khalid. Error using plot. So Which one? This one, FC. So just Khalid, I just told you this first plot FC. Okay, write this here. Line number 19. Go to line number 19.
Okay.
Like put your cursor behind P.
Behind B.
P behind P. Yes, behind.
Okay.
One minute. Yes, enter. Press enter.
I press enter.
Yes, press enter. And then here, write this code. Stop sharing your screen. Write this one here. This before plot. Write this. Okay, your plot is here.
Axis.
Axis for first one, and this plot then axis, and then
Okay. Do you have to write it also, Doctor?
sorry.
Do you have to write it also?
No, titles and these things are not needed.
Okay.
These bands and all. Okay, Khalid, it's working for you.
I'm writing right now.
Done? Minus 12C and then space. Zero point six. want your name. And I will, it's better if you just take a screenshot of this with you.
There is something wrong, doctor.
Yes. What happened? Show me, Khalid. Which plot? This one. F with capital C. Run.
Sorry, doctor, your sound is not clear.
And there you can use it now.
Doctor, there is no sound. Doctor, you put it to mute.
Yes, now it's fine. Actually, I was not able to write in your. Okay, can you run it now? Khalid?
Okay.
Is there still error? Can you share your screen?
Okay, I'll share my screen.
Now the unrecognized function A. This should be capital A. Yes, fix. Press the fix. Now run it again. So 2 and n. And then here you didn't normalize this with n. 1 minute. So this is fine. This final modulated signal is fine. But here, can you see that you didn't normalize this with n? Yes, this is fine now. Yes. So Khalid, can you tell me which is this signal? Which one is this signal?
The last one? For the last code?
No, just go up. Yes, this one. Which one
This
is
one.
this?
The XTABS.
Yes, but this is carrier or message or modulated. Which signal is this one?
Signal.
Yes, this is carrier signal. Okay. If you go down,
Okay, I can go down.
So which one is this signal? There are two bands. So which signal is this one? This is my message signal. All the information is contained in these two bands. We are seeing the frequency spectrum of the message signal. So if you go down, then you see this. This is your modulated signal. Okay.
Okay.
This way you can check your results. Yes, done. Yeah, yeah. I will take your attendance. 1 minute. This is section 3.
3.
Okay. So today, Ali Hussain. Ali Hussain is present.
Yes.
Okay.
Correct.
Mariam. Mariam, is this screen shared or what? So, okay, Khalid, can you stop sharing your screen? Share my screen. So, okay, Mariam Al Muhammad. Absent. Okay, Latifa was present. Salma. Okay, sorry. Okay, Hamad is absent. So Hamad 191078. You are here. Okay. And then Thamir is present. Salim is present. And Khalid. Yes. Abdurrahman is present. Ritaj. Yes. And Abrar is present. Taif Adnan. Okay. Yes. So I will make your assessment today for lab 3, and then I will post it on Moodle in week number in this week. Okay, 24th of October. Okay, I will post it here, down here. Okay, and then you will have 3 days to submit as usual, and then I will accept the PDF only. Right?
Doctor.
Yes.
Please, we discussed about the submission. We took maybe the second lab. We tell you put it, please, 1 week. It's okay with the 1 week. I didn't submit the lab 3.
You didn't submit it. This was the link. This was the lab. You didn't submit it?
No, because I think it's about 1 week. Because we discussed about this.
Okay. So I will increase it for 1 more day. Then you can submit it. Okay, 1 more day.
Okay.
I will increase this. Okay. So
Also,
it will be now 26th October. Okay.
Okay, Doctor, about lab 4, please make it 1 week. It's okay. All lab, Doctor, make it 1
You
week.
know what happens in 1 week? I forget. And then you will have your midterm in the next week. Yes. So it's better if you put it now, so that during your midterm I mark all of them. So do some favor to me also, because I have to mark all of them. So if you for this until Thursday, okay? Thursday is fine. because then I will have a long weekend. I will mark all your assessments. Okay. Thursday, I will put for today here until Thursday for assessment 3. And for this, I will increase one more day. Okay. Or until tonight is fine. Tonight is fine.
It's 1 week, it's 1 day, not okay, but tonight,
Tonight, yes.
not
Tonight
okay.
at 12.
I was thinking about today.
Okay, you can work
We
on.
have many works, doctor.
Okay, okay, until tomorrow. Okay.
Okay.
Okay. So anything else? Okay. Thank you. So done for today. Any questions?
Thank you, doctor.
Okay, then take care and then submit your assignment, assignment 3 until tomorrow, and then assignment 4 until Thursday, right? Okay, thank you. Bye bye. So the Zoom meeting is over.